on. Supposedly, in this week, we have to go to the next chapter, which is chapter 4, as scheduled in the lesson plan, geotechnical modeling using numerical approach. However, I think that the more column new criterion is much close to the geotechnical modeling. So before that, I think that you need to prepare some sort of the starting from now on. Try search any geotechnical project or case study that can be made as your own project case that you will be answered, or you try to simulate using the geotechnical modeling as part of the cost assessments. So the project will carry I'm not sure what's the percentage. Let me check first. But there's a percentage that you need to consider in the geotechnical project. So there will be a changes in the lesson plan for chapter 4, which is akan ada satu minggu yang mana you all need to do on self-taught online numerical modeling lah. So if you see from here, I think that just to refresh every one of you what we're going to have from this course, because from that you dah tahu your chances untuk let's say you are planning for score, or you are planning to up your grade CGPA. So this is the thing that you need to aware, which is project brings to you 24%. So common test has been done 30%. So remaining on the project 24, quiz 10%, and final assessment 36. So the quiz, as what you can have, is actually by attending the online class 5%, and another 5% is answering the questions. So meaning that you need to participate the online geotechnical modeling offered by any website that applicable for you to have your own certificate the end of this course. So the certificate will be part of the evidence to give you 5% in hand. So if you are not accomplished the module of the online course, which will affect to your 5% marks. So just to make clear every one of you on this matter. And not to forget, for your information, next week will be Dr. Ng Kok Shen. He will taking the class until to the last week of the semester in week 14. So I hope that there will be no problems on that matter, because I still in the group. However, the online teaching or whatsoever face-to-face lecture will be given by Dr. Ng Kok Shen. Okay, saya harap anda semua bersedia untuk minggu ni dan minggu seterusnya sebelum kita ada cuti festival pada 22 hari bulan, pada 25 hari bulan 12 is a festive leave. So 25 hari bulan 12 kita akan cuti lagi selama seminggu. So makna kata you boleh rancang lah apa yang sepatutnya anda buat dalam tempoh 3 minggu ni kan. Kemudian nanti naik daripada cuti holiday tu, you nak kena submit project ke apa benda. So dah plan from now lah. So jangan buat last minute, sebab this is a project yang 24 marks. Kalau kata you tak buat in a good way, so there will be deductions in mark lah. So boleh cover balik lah mana yang test hari tu rasa tak berapa nak perform. So tolong make it good lah for next one. Okay, saya harap every one of you are fine, and yelah kan kita dah habis cuti semester, so back here dengan new and fresh what we call it, fresh energy lah. And untuk makluman anda juga untuk minggu depan selama 3 minggu dan seterusnya lah, supposedly it's a face-to-face new class. So kalau you look back to the our what we call timetable. So the class will be at Makmal ICT. Makmal ICT, which is in the area of, I think that kalau dekat Blok Perdana tu, Aras 2, you pergi dekat Makmal Komputer kan, yang ada Plexis tu, Makmal T or Makmal C, something like that lah. Kat situ kita akan hands on Plexis lah for next 3 weeks. Kemudian remaining topics pun kita akan buat face-to-face class di Makmal tersebut. So anything will be in touch to the WhatsApp information, dan juga yalah, you can personally ask or whatsoever. So now we go to the chapter 1 to 1.2, which is more column. So what is important about more column? So this is part of the what we call it from the chapter 1, which is stress-strain relationship. So I think that as I explained in the earlier class, when you have a kind of material, the material can behave in a way of linear only. It also can behave as a linear elastic, and it also can behave as a linear elastic perfectly plastic. And somehow the material such as soil may not behave linearly. So the material will behave in non-linear. But the difference about non-linear and also linear, it goes and it comes back when you are dealing with the design and analysis. When you are taking the real problems on site, for example, as a real behavior of the soil, considering as a non-linear, you may have a good design. However, if you consider the material as a linear elastic, you may have such as over design. So what is the effect of over design? It comes back to the cost of the project. Somehow, it's not about the overestimated design. It also can have underestimated design, which is not represent the real soil behavior. So as such a technical engineer, as part of our students, you may need to understand what will be the best constitutive soil behavior that represent the failure of the soil. For example, why you are exposed to this topic is due to the some of the part in numerical modeling in Plexis is you need to assign material or behavior of the soil. So by clicking the right constitutive soil model, either you have linear and then you have the Moore column, or you have the Drucker-Prager, or you may have a hyperbolic model, or also can have the advanced soil model. They will tell you exactly what are you going to have at the end of your analysis. As what I said, some of the material will behave differently according to the type itself. But the part is you have to familiar with the material parameters, and then how it is behave when it is subjected to loading, whether it is in undrained condition or drained conditions. Either you are using the correct effective strength parameters or total stress parameter. So these are the things that you have to check through before you assigning in the numerical software. And then when you have to this Moore column failure criterion, is part of the F is represent to the yield criterion. So you may see that these are the three axes represent the stress point for the material in the sigma 1 major principal stress, intermediate principal stress, and also the minor principal stress, sigma 1, sigma 2, and sigma 3. So the stress point or the stress that you present in three-dimensional will tells you the yield criterion from 1A, 1B, 2A, 2B, 3A, and 3B. 1 is represent to principal normal stress 1, and principal normal stress 2, and principal normal stress 3. So the yield criterion for each locations of the stress point having by these equations. So right now you may see that relations between the internal effective internal friction angle as well as the internal cohesion of the soil. So how it is relates. And then This is what we are trying to explain when you have a more column. If you remember, when we dealing with the failure of the soil, when you are conducting triaxial sample, triaxial test, for example, you may have a different behavior of this failure in UU, CU, and CD. And the failure of the shear represent the mode of the sample by end of the stages, for example, from the consolidation stage to the shearing stage, as well as the effect of the pore water pressure. And from the experimental, it is derived to you the strength parameters of the soil, such as C and also the phi. And if you remember, the Moore column will tells you the exact of the Moore circle and as well as the failure uh, failure equations, which is tau equal to sigma plus sigma n tangent phi. So how this deriving is coming from the Moore circle plus column failure criterion. That's why when you are having to determine the strength of the soil, you need to plot the Moore circle, and then by substituting into the equations of the failure criterion, you may have the answer of what is the C and as well as what is the phi by graphical method, or you can use the equations. So let's say by looking at one example here, you are subjected to the normal force as a F, and then you are applying as a shear stress T. And by converting into the stresses symbol, you may have a normal stress, effective normal stress, acting perpendicular to the plane, and you may also have the shear stress that acting parallel to the plane. So it is deriving in the column equations as what you can have is a T is lesser or equal to the A plus F tangent phi, which you may have as a linear equation that having A intersections and also the tangents, the angle of this linear line. Whereas when you convert into column equations, this is what I explained just now. You may have the C that intercept on the y-axis, on the shear stress axis, as well as you may have the internal frictions angle, how it is deriving from the normal stress to the shear stress. And then in general, if you remember how it is derived, the shearing process, and when you acting or when you act any external load on the plane or on the surface, this is the conditions where the shear stress, let's say, equal to lesser with the effective C minus sigma n tangent phi, which must hold for arbitrary angle theta. The theta is represent the shear angle. It is not similar to the phi. So what we may have from here, there are two strength parameters, that is ineffective cohesion and also the effective frictions angle. I think this is a quite common seen, the deriving from the one stress adding to the plane, and then you convert to the Moore circle. This is what we may have, which is represent to the minor principal stress as a sigma 3, and also you may have a major principal stress as a sigma 1. So the ideally, it also the stresses can be presented in the coordinate in y axis and as also in the xy axis. So xy is a coordinate where the stress is at, whether it is y plane or in the x plane. And remember, when there is a normal force that also having a shear stress or normal stress, we may also have a shear stress. So the equivalent expressions, this what you also have if you are deriving from this left side to the right side, where you determine the what we call it here is the failure point to the tip, and then you may have the C. C is from the origin to this point C, and the remaining as what here is the S. So the taking back to the equations, that the changes from the original equation to here as a T is lesser or equal to the effective C cos phi minus C sine effective phi. So what is exactly the T, C, S and phi? So this is, if you remember, if you are presenting in the stress pass, remember last class before midterm break, I have explained on the different stress pass that represent the failure line or the failure point of the samples. So whether you have the total stress or you may have effective stress. And this total stress, effective stress will show you differently if you are conducting for undrained triaxial or drained triaxial test. So the T, C and S is actually represent to the pass of the samples in the T and also S. It is average and it is a mean stress pass. So when you come back to here using the major and minor principal stress, and when you are deriving the what is the exactly equations that you can relate between the effective major normal stress and minor principal stress by taking directly from this one, and you rearrange the equation. This is what you may have. So negative is represent to you the samples in the compression mode. Normally, what we can have is that the measure or the sigma 1, effective sigma 1 is the major principal stress, and effective sigma 2 is the intermediate principal stress, and effective sigma 3 is a minor principal stress, which also tells you is that this effective sigma 1 is larger than effective sigma 2 and sigma 3, and effective sigma 2 is larger than sigma 3. So this is why we call it here the effective sigma 3 is a minor principal stress due to the value it has. Okay, when you want to visualize of the Moore column failure criterion, remember that from the Moore column failure criterion and also the stress pass, these are the parameter that you may have from the stress pass between T and S is A and also the B. B is a coefficient of the sample at the coefficient of the lateral earth pressure. The same thing that when you relates to some sort of the pre-consolidations, and then you want to see further what is the what is the C and D at here. This is what you may have from the graph by having one equation here as A minus B effective sigma 3. So you substitute to these equations, you may have what is exactly C star. So C star ni dia boleh tahu pada awak lah macam mana the material visualized in the number or in the figure. Okay, same goes here. Yang ni untuk conditions kalau full Moore column criterion. At the first slide just now at the yield criterion. So when you look at to this Moore column in deviated plane, you can see some sort as 1, 2, 3, 4, 5, 6. So hexagonal shape. So hexagonal shape also represent to you the compression point, and then it also has the extension point. And when you look at to this one, the A1 and A3 is equal to 3 plus sine effective phi over 3 minus sine effective phi. So on your part, here is only focusing on the Moore column failure criterion. When you go to the next level in the chapter 4, when you are modeling and simulate using Plaxis, you may see there is a lot of the models to be to present or to tells you the behavior of the sort itself. It's not only having a Moore column. You may also have a Drucker-Prager, or you may also want to analyze as a nonlinear by using the hyperbolic. But again, before choosing what is the constitutive soil model that you may use in the future, you need to know the pro and con about the model. And other than that is material properties. The material properties are important for you to determine the best quantity soil model in your numerical modeling. Okay, I think that this is the common when we talk about soil, logically, and I think the simplest thing lah, we want to use the Moore column, but then the Moore column is not anymore as a linear. It becomes as a linear elastic perfectly plastic model. It means that when you want to visualize, so the things that you may have at the end is some sort this way. You akan ada satu part yang mana dia mewakili linear portions that you can have as a Hooke's elasticity materials, and the other part is the plasticity zone or plasticity regions. The plasticity regions indicate to you the Moore column failure criterion. So the LEPP model with Moore column failure contour is sometimes called Moore column model. So when in geotechnical engineering, when you have the Moore column model, actually you can visualize that it consists of elasticity zone and plasticity zone. So for this model, so the plasticity zone indicates to you the failure of the sample, but it is not applicable to all models. So be careful on that part. So this is what I explained just now. You may have on the linear elastic or linear regions at this side, and then when you still continuing or applying stresses, you may have at one time the stress remain constant. However, the elasticity strain continuously increase. So you akan nampak pada keadaan normal stress you dah mengalami keadaan malar, tapi nilai strain masih lagi meningkat. At this part, you have a part of linear regions, and the other side here, it is a failure regions or plastic region of the sample. So the other thing is that from here, the yield stress is equal to the failure stress for perfectly plastic. So this is the conditions when you want to explain the zone of the plastic for Moore column model or linear elastic perfectly plastic. So yield stress is represented by Y naught. So what is the strain? Strain consists of elastic strain plus plastic strain. So I think that I will not explain to you what is the strain is all about. So you have to return what exactly strain, and then why the strain consists of summations to the elastic strain plus with the plastic strain. Logically, what do you need to know is the zone where the zone indicate to you as a elastic strain, and the other side where is the zone represent as a plastic strain. And the combination between elastic strain and plastic strain is a total strain for Moore column criterion. What is the important about the strain increment and also the strain of the Moore column model? So the increment meaning to you the changes which you can see before and after apply loading. So what the strain is I explained just now. So if you want to see the strain increments, you need to subtract or difference the strain value before you apply loading and after reach to the failure. So you can see the strain increment from 0, for example, to the sum value. The strains of the increments are divided into elastic strains and plastic strain. A soil model relates increments of stress to increment of strain. So why it is said? Because it is back to the linearly elastic perfectly plastic. That's why some sort kita kata dia berkadar langsung lah. Okay, if you deriving the Moore column in the past of the criterion, you may have that from here. The elastic strain increments from the Hooke's law. The strain is equal to the 1 over Young modulus multiplied with the this kind of the matrix for Poisson ratio multiplied with the change in the sigma or we call it as a stress increment. This is what it says, that the strain increments are linearly to the stress increments. So the relationship is connected by having one coefficient, which we call it as a Hooke's law coefficient or the Young modulus. Okay, when you go just now is on the elastic zone. Right now, when you talk about the plastic strain increments, this is on the flow rule. Flow rule, we also can have a associated flow rule, or you may also have non-associated flow rule. So the flow rule is the changes in the plasticity of the material. So it is can be presented by the changes in plastic strain is equal to the changes in one coefficient times with the changes in the plastic potential over to the changes in stress. So this is what it means to you for each symbol here. Okay, the delta sigma here is the directions of the plastic strain in the vector. So the flow rule can be defined if you having a changes that subjected to the for water pressure. For example, if you want to see the volumetric strain, and then you want to see whether it is in associated flow rule or non-associated flow rule. So the ideally is symbolized by having this kind of the plastic potential is equal to the yield criterion, so that we call as a associated flow rule or associated plasticity. If you have that, the plastic potential G is not equal to the yield criterion F, so now we call it as a non-associated flow rule. The other thing is that if you want to know whether you have the associated flow rule or non-associated flow rule by looking at to the value of the internal frictions angle and also dilatancy angle. So the dilatancy angle, if you are taking the dilatancy angle equal to the internal frictions angle, so we can have the sample as a associated flow rule. Vice versa, if you take it the dilatancy angle is not equal to the internal frictions angle, that is a non-associated flow rule. So what are the effects? You can see that when you have some sort like as here, if the yield criterion less than 0, so it is purely as an elastic behavior. If you have the yield criterion equal to 0 and the yield increment is less to 0, so this is the conditions of the elastic behavior, unloading from a plastic state. And if you have if you have F equal to 0 and the yield increment is equal to 0, so this is the elastoplastic behavior. How about if you have the yield criterion more than 0? So this is non-acceptable stress state. Maknanya dia hanya berlaku dalam case 1, 2 dan juga case 3. The conditions. Okay, the yield criterion, as I said, from the condition 1, condition 2, and condition 3 can be presented in the stress path or in the yield path in sigma 1, sigma 2, and sigma 3 as what I have here. Okay, and the criterion is bounded by this shape, and then the plasticity, if you have that yield criterion within this region, so this is, we call it as a plasticity. If you have the yield criterion out of the border or the boundary of the yield stress, so this is the unacceptable conditions. So for Mokulum, it's actually easy to be used, to be applied, and to understand, because of the number of parameter also easy to obtain. But as I said earlier, the model can give you overestimated design and also underestimated design, which not exactly represent the real behavior of the soil on site. Okay, never mind. So So let us go to the next one, is a basic concept of the Moore column model. As I explained just now, for the Moore column model, we may have the elastic region and also the plastic regions. So what are the important about the elastic region and also the plastic regions? The Moore column is happening at the plastic region, but then it also consists of the elastic part, elastic zone. So at this part, the elastic or linear zone which you need to determine the elasticity parameters. How to get the elasticity parameter, how and what are the parameters that relates to elasticity parameters. So imagine that you have one sample here subjected to external load. In compressions, this is the changes that you may see where the sample may compress in vertical and also it may extend in laterally. So that's why here you can get that changes in major strain and also changes in the minor strain, normal strain. So when you plot on the axis graph, this is what exactly represent to you two parameters under elastic regions. For the first one is the Young modulus, which is the tangent of the linear line, and then the next one is the Poisson ratio. What is the Poisson ratio? Poisson ratio is a ratio between the lateral strain to the vertical strains. So the delta strain in 3 over to the delta strain in 1. If you look at here, strain 1 is the vertical directions, strain 3 is the lateral directions. So that's how easy for you to determine what is the Poisson ratio. It must be a ratio. The ratio also varies according to the soil type. Whether you are modeling for clay or model for sand, that will be given you different value for Poisson ratio and also the E, Young modulus. Okay, how to alternatively relates the elastic parameter? You may also have the shear modulus. You can also have the bulk modulus, or you can have the Young modulus, but from odometer test, or we call it here as a odometer modulus. So the modulus E from odometer can be obtained from this relationship between Young modulus and also the Poisson ratio. So somehow when you do not have any what we call it typical values for these two parameters, you need to find by having the analytical equations. So you kena dapatkanlah the Young modulus E odometer sama dengan E times 1 minus Poisson ratio over 1 plus Poisson ratio times 1 minus 2 Poisson ratio. Okay, the E here is not similar to the E odometer. So you kena nampaklah the differences between E odometer dan juga E biasa. E biasa ni I mean that kalau you conduct experiment from triaxial test lah. Okay, what about the plasticity parameters? So plasticity parameters is actually that we have from here A and also B. In between A and B, there are two common parameters that we always seen for shear strength parameters, which are C and also the phi. So that bila you tengok kat sini on the left figure, if you relates the stress in plane X and Y, and then these are two things that you may have, and then when you convert to the yield criterion in the major effective principle and also the minor effective principle, this is what exactly you may have is a and B. So this is the yield criterion. If you remember, the yield criterion is some sort having the hexagonal shape. So hexagonal shape from here is actually represent to you the criterion for the Moore column model. Kalau kata you nak keluarkan strength parameter yang biasa, ini yang kita commonly plot. Kita ada shear stress, kita ada normal stress. Ini parameter yang you selalu jumpa, C dan phi. However, when you analyze using the numerical software, this is what exactly calculate in the software by having the A and also the B. Okay, other than that is the, I mean that the number 5 parameter for more column model is the dial latency angle. So dial latency angle is relates to the how wait a second. Okay, the dial latency angle is some kind of it's very important because it is related with the volumetric of the soil. Okay, an important aspect of the soil behavior, the angle of the latency perform a similar role in defining the rate of volumetric strain to the shear strain in the MC model, as the friction angle in fixing the rate of change of the shear strength with the effective mean strength. So dia akan berkait dengan bila sampel tu mengalami perubahan isi padu, kemudian you nak tengok dia punya sudut antara particles from the initial conditions to the final conditions. So this is what's exactly happening when we are applying a load. So bila kita kenakan beban, you akan nampak the stress increase linearly with the strain at one time. When it reach to the yield stress or yield criterion, when the stress constant but the strain and also the volumetric strain also increase. So this is the time where you need to determine what's exactly the dial latency angle at the yield point. So that's why among 5 MC model parameters, this also cannot be neglected. Okay, this is how it shows to you the MC parameters in the train triaxial test. If you want to determine what is the what we call it here, the effective E, and then the effective Poisson ratio, and how it is deriving from the linear elastic perfectly plastic, and to the dial latency angle, the volumetric change, and exactly when you plot the graph, this is supposedly what we have is some sort of non-linear. But then when we want to model as a more column, you will have as a straight line at the linear zone as well as a straight line at the plastic zone. But this is not exactly represent the real behavior of the soil. What you actually have is a non-linear. This is what it says that. But since you opt to analyze using more column model, we assume it as a linear elastic perfectly plastic with a certain 5 number of parameters. Okay, this is what it says that for odometer Young modulus. Okay, and then please highlight there are 5 important model parameters for more column. The first one is the Young modulus, second is the Poisson ratio, C is the cohesion, phi is the friction angle, and lastly is the dial latency angle. So the model parameters must be determined such that the real soil behavior is approximated in the best way. So dalam 5 parameters ni kita boleh dapatkan daripada eksperimen lah. Yang terbaik tu you conduct eksperimen, kemudian you plot graph dia, you keluarkan what is the E, Poisson ratio, what is the C, P dan juga dial latency angle. So yang ni yang dia cuba sampaikan lah kalau you ada real testing result, and then this is how you can get the effective Young modulus at the tangent of the linear line, and then the dial latency angle. What are the things that you need to remember about the Moore column? It is a good failure criterion for soil. Which soil can only fail in shear? The soil cannot fail in compression. So the friction angle of soil is a material constant. So benda yang memang akan ada lah dalam molecular model bila you design behavior of soil. Okay, what are advantages? This is what I said when you opt or when you are selecting any constitutive soil model, sama ada more column ke, Draco-Prager ke, hyperbolic ke. So mana yang terbaik lah. Antara advantage of the more column is a simple and clear model. That's why I said it's very easy lah in terms of the data parameters, and it's only involved with the first order approach of soil behavior in general. It means that dia punya year criterion tu just application ataupun the first order. You tak perlu complex equation untuk dapatkan dia punya criteria year function ataupun the year criterion value, and it is suitable for many practice. The limited number and clear parameters how and why it says limited number and clear parameters is due to the number of parameters for sure. You tahu 5 saja. Okay, we are back. Net problem. Then changes the material having a deformations, there will be a volumetric behavior or the volumetric change. So when you have this kind, you sebenarnya dah ada satu part kita panggil parameter tu memang senang nak jumpa, senang nak tahu daripada eksperimen. So you plot graph or you ambil tangent of the graph, you dah dapat E. Kemudian nak dapat Poisson ratio, you masuk balik dalam formula yang saya tunjuk kat atas tadi kan untuk dapatkan dia punya nilai E. If you want to get the odometer parameter, just reuse or resubstitute the value you obtain for the first one E from the tangent of the graph. Mana masuk balik dalam formula dapat odometer E. So it says that, that's why it says that it is very easy and clear to use the more column model. So dia tak complex. Other than that, when you are dealing with a complex or advanced constitutional model, some parameter is not easy be found. Sometimes you need to do advanced experimental work just to get this kind of the parameter. And other than that, you need to really understand the behavior of the material. For example, commonly you are known that if you having a clay, you may see that clay is a clay which have a highly plasticity. Tapi kalau kata you really study on part of the clay, you need to know normal consolidated clay ke, over consolidated clay ke. So dia akan lagi details lah. That's why for the beginning, it is advised to you to use the simple more column model. But depending on the applications of the or depending on the case study you. If you are dealing with some kind of excavations, so maybe more column is not more realistic to be used. So you need to find out what is the best constitutive soil model that can explain and tells you the retaining wall behavior when it is subjected to excavation stages or excavation process. This is very important for you to have some overview about the software, about the site project, about the input of the materials. So just to remind every one of you for the next coming class, because next coming class is on the geotechnical modeling, numerical and simulations. So please get notes on the Platsis and then determine or just overview some idea, refreshment review, how many methods available in Platsis, and then what are differences method A, B, and C, and D, for example, and then what is the best, if you have method A, B, C, and D in Platsis, what is the best method can be used to model your problems. And then I recommend you to get familiar with the Platsis before you doing your projects. So it's good for you to have that part because dia akan jadi value added lah for every one of you, because kita tahu kan now is a IR 4.0. It's become value added kalau kata potential employee coming with the X factor, yang mana all other candidates do not familiar or expert in numerical model, but somehow you can do that one. So if I am become your future boss, I will choose you as if you heard from previous talk handled by our faculty. The industry panel says that the Industrial Revolution 4.0 is part of it is numerical model simulations and also IoT database and cloud. So kalau kata you all memang power dekat part-part tu lah kan, memang tip top lah kan, kalau you pergi interview senang lah potensi you untuk dapat lah. Okay, the next one is on the disadvantages. So bila kita promote more column, it's not that more column tu yang terbaik, dia ada lagi advanced model. Kalau you tengok daripada gambar-gambar slide yang saya pernah tunjuk awal-awal tadi kelas tadi the exactly happen when you plot the triaxial test is actually is a non-linear behavior. So bila you plot graph tu, kita akan dapat non-linear plot. But due to the assumptions in the more column, we may assume that the model is behave like a linearly elastic, perfectly plastic, but inaccurate happen for real situations. So these are the things that limitation on the more column model. For example, it only can be applied on isotropic and homogeneous behavior. So kalau kata you go site and then you find out from your borehole the material or the samples is heterogeneous, so that it is not applicable anymore to use more column. But somehow you need to make few assumptions lah. Kenapa daripada heterogeneous soil model, from the heterogeneous soil profile, you still want to use more column model walaupun dia dah stated dah. More column model, dia punya limitation untuk isotropik dengan homogeneous behavior saja. Kalau you nak predict other than that, selain daripada linear elastic perfectly plastic, so dia tak sesuai. More column model bukan lagi yang model sesuai. Kemudian, it until failure linear elastic behavior. Benda yang realitinya bukan begitulah. Kalau betul-betul you tengok, if you remember conducting the triaxial test for undrained, unconsolidated undrained, as long as you apply loading, you may see that the sample keep increasing the bulging or deformations. Even though it's actually you dah nampak dah crack surface, dia dah ada shear plane semua kan. Tapi selagi mana you kenakan lagi beban, dia still lagi can produce to you the readings. But that's why I said lah, kalau you ambil more column model, dia dah full stop kat situ. Tapi sebenarnya dia bukan begitu. So kalau betul untuk any cases applications in geotechnical, whether it is foundation ke retaining wall ke, kemudian you want to do embankment consolidations kan, slope stability, so you have to choose the right one, which method in Platsis yang suitable for your case study, and also what are the consistency models available in Platsis that suit your problems. So justifications and few solutions recommended before you choose the right one. So as part of the geotechnical engineer duty and role, you kena ada few selection solutions sebelum you betul-betul finalize mana solution yang you boleh pakai. Kemudian no stress dependent stiffness, no distinction between primary loading and unloading or reloading. Yang ni pun betul sebab kalau you nampak tadi dia punya images for the failure criterion is like one way saja kan. The latency continues forever, no critical state, undrained behavior not always realistic, no time dependency. Ini tak sesuai lah kalau you nak study on the consolidations ataupun on part of the embankment on saturated soil kan. Okay, yang ni adalah perbandingan ataupun kenapa some I said earlier yang mana more column ni can be as a overestimated design ataupun underestimated design. For example here like this bila kita plot dalam triaxial, this is what exactly you may have. For example, at the beginning is linear and then non-linearly. Until at one point they reach to the failure maximum. That is the real behavior of the soil having different of the Young modulus. Dia punya varies linear, varies of the elasticity of the modulus. Due to what? Due to having a non-linear shape. Maknanya bila bagi satu point ke satu point, bila dia banyak bentuk non-linear, of course logically you will have a difference yang modulus kan. But then when you opt as a more column model, you may have a one yang modulus constant saja, but not the real situations on site. So benda ni, yang ni lah kita katakan dia sebagai overestimated lah. Padahal kalau you split it betul-betul, the E cannot be taken as a one value or constant value. Okay, how about the other things yang ni pun sama, it's just highlight kat sini, the MC model cannot provide good matches at all stages of excavation in soft clay. So if you are dealing with the excavations project or any case study, sama ada applications, excavations for retaining wall ke, excavations for and mostly for retaining wall lah kan, you akan nampak the Young modulus is not constant throughout the excavation process. Sebab apa? Bila kita buat excavation dia kita punya tanah tu, kita dah digging kan, kita excavate, dia punya nilai stress berubah. So macam mana kita boleh kata dia constant untuk this kind kan, walhal you tahu makin lama dia unload, stress akan mengalami perubahan. So in order to analyze the right one, you have to opt another constituent model side of the column. Okay, apa implications dia? Yang ni yang saya bagi tahu, implication dia adalah overestimated. Okay, yang ni pun the same thing jugalah. Okay, yang this is example, if you opt to have a excavation case project, kemudian you nak dapatkan nilai undrained Young modulus. Undrained Young modulus ni, kalau kita tak guna equations kita kena guna typical established data. For example here, if you have some sort of a case from Lavender stations, so you can have the EU over CU equal to 500. So nak tahu undrained Young modulus tu berapa, so you kena tahulah dulu undrained coefficient. Kemudian you substitute, barulah you boleh dapat nilai EU. So same goes to other project, contohnya Syed Alwi project, Roko complex. So this part also can be taken as your study lah. Contoh, you want to see the effect of the various Young modulus in undrained condition. For example, the application to the deep excavation retaining wall. You tengok dia punya kajian case. Kalau kata you ada 5 cases having a different Young modulus, you see closely. This value may affect to your final deformations in terms of the effective stress ke, in terms of the plastic strain ke kan. So you boleh tengoklah dalam praxis tu. Kalau kata Young modulus is very significantly impact to your retaining wall deformations. So what are other things, parameter juga yang you kena consider? Yang tu pun you boleh ambil sebagai satu variable, dependent variable ke independent variable or parameter in your study. So the thing is that get familiar with the Platsis, kemudian buat self learning ataupun self taught dulu pasal Platsis ni. Dan untuk makluman awak juga, kita try fokus Platsis ni kepada 3 dimension Platsis. Okay. Kita dah habis untuk one part ni. Saya cuma nak relate satu lagi lah. Yang ni, nota tambahan ni, saya dah attach dalam YouFuture. So jangan lupa buat learning activity YouFuture. So kalau nampak online class pun kita tak ambil dalam 2 jam sangat lah. Saya akan release you awal. So remaining tu, cubalah buat revision, kemudian tengok balik dalam learning activity apa soalan yang kena jawab kan. So dia penting lah untuk awak punya kelas akan datang yang berkaitan dengan geotechnical modeling and simulations. So just to continue apa perbezaan sikit dia punya signifikan dia kan. Ini yang bila saya cakap lah, the real behavior versus dengan molecular model simulation. In purposely, you kena understand kenapa kita buat simulations. Kita nak buat simulations sebab kita nak faham the behavior of the soil. Just imagine when you have some sort of any geotechnical projects, contohnya retaining wall, you tak buat simulation, you tak boleh nak predict behavior of the soil bila you betul-betul buat dekat tapak. Kalau kata you buat early stage modeling and simulation, at least you can predict what may happen when you are entering to the site project. Maknanya you dah tahu dah. Kalau kata kita ada retaining, last class kan kita belajar pasal retaining wall kan, untuk embedded sheet pile wall, kemudian kita belajar untuk anchor wall kan, just purposely to determine the embankment depth. So from embankment depth tu is actually to present to you or to give some idea for you. Bila you buat numerical modeling simulation dengan D yang you dah determine analytically, you masuk dalam geotechnical software, you dah boleh predict dah sama ada D yang you calculate ni can give you safety condition ataupun dia unsafe. Kalau dia not safe, berapa nilai D yang sebenar. That's why kita buat modeling dan juga simulations. So you can do modeling before, during the project, on and after. Contohnya before ni, you get the input about the soil profile daripada borehole ni. So you dah buat analytical study, you dah calculate nilai D. So you calculate, you masukkan dalam Platsis, you simulate, you dapatkan nilai D tu, you modelkan dia, kemudian you dapat nilai factor of safety, kemudian you nampak the behavior or deformations of the retaining wall, and then from that you dah boleh guess dah. Bila kata kita nak buat nanti ni semasa dekat tapak ni, is this what happened from the simulation you obtain, or it may happen differently from the simulations. So that's the important lah currently. Kenapa the highlighted about importance simulations and also the modeling. Because in terms of the budget, we can cut off. In terms of the time, kita boleh save. In terms of the management, banyaklah benda-benda positif lah. Kenapa kita encourage to have the modeling and simulations. Okay, contoh juga kalau kata you buat UU test, this is what exactly happen lah. You may have different nilai E, represent red color, green color, blue color. But then when you model in the more column, you only have one elastic E sahaja. Yang mana sampel tu sebenarnya pada real condition, it has 3. But now it only has 1. From consolidated grain, same here juga. Cuma nanti you akan nampaklah sebenarnya dalam consolidated grain nilai E tu berbezalah pada green sample nilai E lebih rendah berbanding the red sample. Sepatutnya more column pun dia represent benda yang sama, tapi tak berlaku. More column hanya bagi you one yang less. Okay, how about if you are considering as a elastic model material? So this is what exactly we have. Kalau you kenakan shear stress, you akan adalah shear strain. Tapi you tak ada volumetric strain. Tapi kalau you kenakan normal stress, you ada tak volumetric strain? Volumetric strain, from here, you can shear strain. Okay, from here you akan ada volumetric strain. You kenakan normal stresses confined from all directions, dia akan ada volumetric strain. Okay, kalau you present it dalam bentuk untuk you model tanah clay undrained behavior. Undrained behavior tadi kan kita nampak yang mana kalau real behavior you akan ada nilai E yang sama that represent different samples. Maknanya kalau you plot more column circles tu, this is what exactly you may have. So nilai shear stress dia adalah sama untuk ketiga-tiga sampel. That's why lah dia punya nilai E pun kalau you plot dia akan bagi you nilai yang sama lah. Tapi bila kata you plot dalam more column, so from the non-linear kita assume dia as a linear elastic. So yang kita nak stresskan kat sini adalah the Young modulus is actually behave as a non-linear, it's not as a linear elastic. What are the changes selain daripada real soil behavior or you are using the elastic model? So both having the shear stress and shear strain, but then here similar juga, maknanya masing-masing is a stress independent kalau untuk undrained behavior of the clay. Dan kita bolehlah guna CU dan juga EU. Apa yang penting berkaitan dengan undrained behavior of clay, kenapa kena guna CU and EU? Dia signifikan dalam Plexis. Plexis macam saya cakap tadi, dalam Plexis dia ada method A, B dan juga method C. Dalam nota U juga dia ada satu additional iaitu kita panggil D method. Kalau method A tu they will tell you Plexis material setting lah. A is undrained, B pun undrained, C pun C is a non-porous. So all this part here is actually explain to you kat mana yang you boleh guna method A. Kita nak pakai undrained parameters tu for strength ataupun stiffness parameters. Kalau kata method B undrained setting, more column juga, dia punya strength tu is it total ataupun effective? That are differences. Yang paling obvious perbezaan dalam method A dan juga method B. That's why lah I recommend and I advise to you to have that problems you sama ada undrained condition. Kemudian kalau dia undrained condition, nilai strength dan juga nilai stiffness, is it in the total stress ataupun in the effective stress? So kalau dia total stress, dia total stress of the strength, dia akan jatuh dalam kategori ataupun method B. Kalau dia adalah effective stress or effective strength parameters, dia akan drop dalam kategori A. So the significant for the pore pressure for elastic, you akan nampak the changes from this data lah dalam loading consolidation stage dan juga shearing stage. So the deviated stress is a 30, the changes in pore water pressure is a 10. So mana dia dapat daripada result kat sini lah, 100 tolak dengan 110. So you akan nampak change in the pore water pressure. So deviated stress is a stress between sigma 1 dan juga sigma 3. So yang ni pun stress pass lah. Tapi sekarang stress pass is not S and T and S lah. Dia lebih kepada Q dan juga P. Okay, untuk consolidated undrained ni same thing here. Kalau more column, yang ni yang kita kata dia over predicted tau. Sebenarnya bila dia dah daripada initial point ni, dia pergi ke total stress point. And then they can have the effective stress point ataupun effective stress pass bila you ada pore water pressure kan. Sepatutnya the value at here as a 2CU, it reach to the failure line KF. But in more column, bila you model for consolidated undrained triaxial compression test, dia tak meet failure line dalam keadaan lengkung, tapi dia produce to you dalam keadaan first order, iaitu linear line that meet to the KF, yang mana lebih tinggi nilai deviated stress 2CU berbanding real soil. That's why it says that dia model ni adalah model yang over predicted for this case nilai CU. Untuk conditions consolidated undrained. Okay, similar kalau you relate to the pore pressure. Pore pressure pun nampak dia punya perubahan daripada total stress pass kepada effective stress pass. So supposedly this way lah dalam laluan sebenar tegasan tu untuk dia condition. But then dia tak berlaku because we assume it as a normal considered in a elastic soil. So the predicted pore pressure is much smaller than the measured. So bila yang ni berlaku, dia akan ada result pun inaccurate lah in terms of the final value. Okay, this is another comparison kalau different method, let's say method A dan juga method B and etc. Okay, yang ni case yang kalau you buat this one dia ambil daripada past articles computed using method A, yang measured data is like this tau sebenarnya. Tapi bila dia model pakai method A, you akan nampak the value of the what it says here, the deflections. You will see that the real deform of the wall on site is actually around 300 mm. Maknanya pada level 10 tu lah bila you buat dia punya elevated soil tu, pada level 10 tu dia punya deformations, dia punya deflection is a 3 to 5 mm. However, bila you pakai method A Plaxis, you buat numerical modelling, dia punya deflection tu tak sampai pun to the exact or measured on site. So kat sini akan berlaku wrong reporting data lah. So just be careful when you have this kind. So other than that, when you also use method A for normal consolidated clay. So method A, method B, method C ni semua you kena search balik nota daripada YouFuture under my folder. Kat situ saya dah attach apa dia method A, method B, method C untuk you have revision sebelum you masuk next week punya kelas. Okay, untuk this case kalau kata kita ada satu stress at certain depth the stress subjected to effective sigma 1, effective sigma 3, kemudian you buat deviatoric final stress, and this is the exactly happen ataupun kita assume dia dalam normal consolidated clay, and yang ni adalah equation yang you nak calculate lah what is the failure stress dia kan. You can have this equation. What exactly happen ataupun apa sebenarnya berlaku bila kita guna Moore column Kalau you guna Moore column model, below this line you akan dapat underestimated at the low stress from A to B, whereby from B to C dia akan produce to you overestimated stress, overestimated for high stress. So it means that the MC is not represent the real behavior of the soil on site. Okay, how about the method B? And then other than that one, yang ni adalah summary untuk saya nak highlight kepada anda semua. Kenapa dalam kebanyakan modelling and simulations mostly kita akan guna method B lah. Method A ni if you really understand yang mana you in condition undrained, but the strength and stiffness parameters are in effective stress parameter, still having the Moore column model. The difference is that for method A, stress type masih lagi efektif. Method B pun efektif. So bila kata efektif ni, you dah boleh bayangkan lah kan effective stress yang mana the excess pore water pressure tu kita dah drain out. Effect pore pressure tu kita dah minus out daripada effect total stress. Dengan pore water pressure kita dapat effective stress. The strength itself dalam ni you akan nampak in terms of the strength parameters, method A dia menggunakan effective strength parameters, effective C, effective V. However, in the method B, walaupun dia effective stress condition, the strength parameters are undrained cohesion and also undrained frictions. So yang ni yang saya kata dia berbeza bila you choose for A dan juga B. Kalau you buat kaedah A dalam pad C, dia akan produce you wrong answer. So basically untuk method B ni, even though it is ineffective stress, but the strength in the total stress. Modulus untuk method A, method B masih lagi sama. Poisson ratio, so nu ni can be determined from any typical value. Untuk B kita boleh guna 0.35. So method A, method B dia guna K0 and then method C dia menggunakan KOT. Okay, yang ni pun I leave it for you to have details reading lah untuk tahu perbezaan dia dekat mana. Okay, how do we determine EU ni? EU ni pun dia boleh guna some relations EU sama dengan 300 CU ataupun you boleh menggunakan any other typical finding from published articles, published result. Dalam Praxis tu sendiri dia dah ada manual tau untuk you baca what is the E untuk yang modulus, kemudian what is the new Poisson ratio. Yang ni adalah recommended value from different case study, Moy building, local complex, share RV project, vendor stations. So kalau you guna different software, so different constitutive soil model, ini adalah typical value that recommended to you. Contoh kat sini ya, SIG-CRISP ni, dua model yang you boleh guna, Moore column dan juga hyperbolic. If you look at here, the value for hyperbolic is larger lah compared to Moore column. Because hyperbolic is a non-linear constitutive soil model. Okay, yang ni dia bagi comparison tau kalau you. Okay, hold on a second. Ada kelas. Ada kelas ke sekarang? Oh, sorry. Okay, back here, as you see here, the deflection, wall deflection maximum using different constitutive soil model and using different, we look at the same one. For example, if you are having the SIG-CRISP, we can have that this is the nice estimated for deflection because we are using the right constitutive soil model. Whereas if you are using Moore column, there is over predictions on the wall deflections. So I think that for the major projects or major constructions, it is recommended for you to have the right constitutive model for that kind of soil in whether undrained condition, drained condition, effective stress and total stress. Okay, this is explained to you the changes in stress when you are having a wall deflection, when you have a soil excavation for wall applications. Okay, yang ni dia punya estimated lah, the wall deflection from the first excavation, second excavation, third excavation and to the last step, fourth excavations. So it is actually explained to you the behavior of the material is a non-linear. You may have a E1, E2, E3 and E4. The E also represent to you the situations of the excavated soil from the first 1, 2, 3 and 4. As well as you may see that it is estimated at the excavation number 4, there is a maximum wall deflection around 80 millimeter. So what's happened if you model and simulate for different constitutive soil model, for example, Moore column and hyperbolic. This at intermediate stage of excavations. It means that kalau you nampak dia punya differences from the beginning, number 1, excavation 1, excavation 2, and then excavation 3, and lastly to the excavation 4, you can have the conditions. Kalau kata first is a monocolumn as a linear, and then hyperbolic is a non-linear. The value of course first is a EU. It's very significant, the stiffness parameters on the wall deflections result. And then for the next one, the recommendations, if you are using the value for Undrin E and Undrin C, also recommended for different software and different constitutives model. Hyperbolic is a common non-linear model to be considered in the modeling. So you can opt whether you want to use hyperbolic or monocolumn. I think that for the first one here, if you had Platsis, I mean that you get the software from online, open source, Bentley or whatever. You try to download and do it firstly at your own. Try to simulate any cases from the one you can determine what will be the best case project for you to be considered in this course. I think that the Platsis is very easy because any software, if you get through, they just have the input parameters and use assign, you model, and you get the output. But the important part is try to simulate and try to model to be the same as you may expect to have. For example, kalau you buat mana-mana case study daripada previous research, kemudian you model dalam software, Platsis contohnya, kemudian you dah tahu result. Bila you model, tiba-tiba result tu tak sama dengan Platsis keluarkan output. Dia start having a problems. Other than part dalam modeling juga, selain daripada material input yang saya explain tadi tu, dia ada item lain yang you perlu ambil tahulah, contohnya boundary conditions and mesh discretizations. So benda-benda tu dia akan influence the final calculations you. So at the beginning, for modeling, since I have told you that we're going to use or model 3 dimensions, so try lah dapatkan mana-mana open source software 3D, you modelkan dulu. Sebab project untuk CG 612 dia sama dengan sebelum-sebelum ni. Kalau you dah ada senior yang pernah ambil subjek ni kan, cuba dapatkan dia orang punya project ke kan, buat perbandingan, tanya dia orang. So untuk verifications result Platsis awak tu, you boleh verify dengan mana-mana software. You boleh verify daripada previous articles punya finding. So kalau kata you nak verify dengan software yang lain, you boleh guna Platsis ke, you guna open source software yang lain, contohnya Rosco, ataupun you guna Slope W, tu contoh-contoh software selain daripada Platsis. So selain daripada tu, kita ada software banyak lah. Kalau you Google, ada banyak universiti dah buat software dia sendiri, contohnya MIT kan. So yang you cari software yang you senang guna, kemudian you boleh modelkan case project you and can submit within the time. So any questions from here? Okay, minggu depan Dr. Ng akan ambil alih kelas, kemudian you terus pergi ke makmal komputer tau. So sharp pukul 2, kalau boleh bawa nota-nota yang berkaitan dengan Platsis lah. Platsis ataupun manual Platsis dalam online ada. You Google lah Platsis 3D kan, nanti dia keluar lah manual dia. So you try lah buat dia punya tutorial ke, dia punya calculation kan, untuk you simulate. Any questions? At the first one, maybe you don't understand what is simulation is all about. simulations is something that is part of the predictions lah. Benda yang you tak boleh nampak on sites kan. Contoh kan kalau structure kita nampak bila you letak loading, naik satu slab, you letak formwork, you masukkan konkrit, you nampak benda tu berlaku. Kalau kata untuk soil kan, kita nak buat excavation. Kita excavate, kita korek tanah semua kan. But we don't know exactly how the soil will behave. Kalau kata kita excavate terlalu deep and then kita pula tak predict, tak estimate pun kalau kata dia ada effect water table. We just go for the site and then do the work. So it's not good like practice. It's not good practice actually. So apa yang you perlu buat adalah we call it here as a early stage design. You ada input, you try buat modeling and simulations, and then you come up with the solutions and you come up with the output. Is it the best way that you may have? Is this the things that you may expect on site, for example? Kalau kata semua-semua tu dah buat, kemudian bila dekat site berlaku, it's okay. So kita boleh buat other engineering step, kita buat reverse calculation ke, reverse design ke. Kita dah tahu dia punya prediction wall deflection banyak ni. Kemudian kita buat reverse step, kita undur sikit ke belakang. So kita play around dengan dia punya input, kita play around dengan dia punya parameter, contohnya kan wall depth, wall height, dia punya size tu berapa. So daripada situ we can actually estimate and prevent any failure that may occur on site. So that's the best thing lah I can offer you bila you buat modeling and simulations. Itulah. Ada soalan? Ada soalan tak Nur Arina, kemudian Muhammad Tasnim, kemudian ada soalan tak Luqman, Faris Amirul? Takutlah saya cakap soalan penat tu tak? Diam ke?
Madam.
Ya.
So untuk minggu depan, so terus datang pergi lab and perlu bawa laptop ni ataupun tak perlu madam?
Macam mana? Perlu bawa apa?
Laptop. So pakai komputer kat situ je lah untuk yang Plexis-nya.
Plexis, kita ada license Ori. So you pergi sana jumpa Dr. dekat Mama Komputer. Ikut jadual memang Mama Komputer kan? Dia panggil Mama ICT kan?
Mama ICT.
Dia bukan Mama BOD kan?
Bukan maksudnya madam, sebab itu tengok macam ICT.
Kalau ICT maknanya dia dah provide you desktop. Dalam tu kita dah ada original license. Kalau satu lagi makmal yang makmal BOD tu bring own device, yang tu you memang kena bawa laptop sendiri. Kemudian bila laptop sendiri, apa yang selalu student buat ni adalah you mungkin ada pirate license, betul tak? So since kita dah beli yang original license, so we encourage you to have a modeling and simulation using the full versions ataupun full license lah. Full license ni yelah kita dah ada benda tu kan, bendanya mahal, lepas tu tak guna, kira waste lah kan. So untuk your punya part to have personal self learning ke ataupun personal hands on, yang tu saya tak menggalakkan, tapi saya bolehlah bagi cadangan. You bolehlah ada crack versions untuk you buat study punya hands on. Kemudian you boleh ada tutorial daripada Plexis tu sendiri, and then you boleh ada YouTube video tu kat situ banyak kan, you Google sikit sambil you hands on, sambil you tengok video, sambil tu you buat. Paling tough about numerical modeling software ni, bila you run calculations, dia tak keluar result ataupun error. Dia bukan macam MATLAB tau. MATLAB bila dia ada error, kita boleh trace balik dekat code yang kita key in kan manually tu, source code tu. Kalau macam Plexis ni, let's say lah you dah run calculations. Dia ada dua possibility conditions may occur. First one, bila you run dapat result. Semua orang suka run dapat result. Second one, you run tak dapat result. Kita pergi ke first one, output dapat result. The next one is you kena verify. Sebab dia macam garbage in, garbage out lah. You macam main game, you masuk apa input, you masuk apa-apa accessory game you tekan button, you boleh main kan. Maknanya akan adalah opponent you kalah ke, you boleh pergi ke next level. Same goes to Plexis. Output dah ada, you dah boleh keluarkan result dia, you dah boleh plot antara apa dengan apa dalam Plexis tu kan. Paksi Y apa, paksi X apa you nak dapat. Macam mana you nak verify result you betul ke salah? Itu yang first thing. And second thing yang orang tak suka sangat bila you run software and then dia ada error, dia tak keluar apa result. Somehow selain daripada tu, yang saya tak encourage you menggunakan personal laptop is due to laptop punya capacity. Sebab dia nak running calculation tu, dia perlukan RAM yang besar untuk dia buat kerja supaya nanti dia tak hang, dia tak jam kan. Sebab dia punya calculations ni, apa yang saya tunjuk pada awak ni is one element. Tapi sebenarnya bila dalam software, dalam Plexis contohnya, dia pakai finite element. Finite element ni adalah elemen-elemen yang dia bahagikan lagi kepada beberapa point yang very smallest. That's why when the computer doing calculations, it's not taking 1 minute to solve. It may take longer than that, 1 hour for example. And kalau kata problem you very complex and depending on the mesh also kan. Kalau kata mesh you pakai fine mesh, dia akan lagi panjang proses, dia akan lagi lama. Kalau kata you hanya guna coarse mesh dengan RAM yang sedia ada tu okey. So dia pendek lah untuk calculation, output senang kira. And bila dah tunggu lama tiba-tiba error pula kan, tak ada result. Kat situ problem yang orang cuba elak. So apa yang you boleh buat adalah you baca dia punya betul-betul calculation step tu. Kalau ada font color merah tu indicate you critical thing yang you kena point out balik, tengok balik apa punca. Mungkin you punya boundary condition salah ataupun input ni you masuklah apa-apa input pun dia betul. Cuma nanti kan bila kita buat verification ataupun kita buat checking tu, kat situ boleh trace lah. You cerita contohnya excavation, wall excavation. You pakai method B. Contohlah method B tadi dia bagi tahu material setting dalam Plexis is undrained. And then stiffness parameters is effective. Kemudian strength parameter sepatutnya undrained, tapi tiba-tiba you guna drain. Kat situ kita dah discover. Kalau kata input you salah, tak tally daripada manual setting Plexis, yang you assign pun salah, automatically yang you report tu semua masuk tong sampah. Tak ada guna lah maksudnya kan. So kat situlah yang you kena hati-hati. Bila you nak masuk input, Plexis boleh keluarkan apa saja output yang you masukkan. Masa verification tu, masa you submit checking tu lah kita boleh trace. Oh ni salah, ni salah. So read manual or identify. Kalau kata you tak nak baca manual untuk semua application, point out mana betul-betul application yang you nak guna dalam Plexis. Fokus kat situ and then get familiar dengan dia punya tools, dia punya tab dia tu kan, dia punya function dia, supaya mudah lah untuk buat kerja kan. Kalau ikutkan Plexis ni untuk chapter 4 3 minggu. Lepas tu kita masuk chapter akhir 3 minggu, tahu-tahu dah masuk revision week. And then submission project pun luckily dia letak dekat minggu akhir. So masih ada masa lah. Cuma jangan buat kerja last minute. You rasa benda tu mudah, tapi bila you betul-betul hands on baru you tahu apa masalah. So my advice to you, kalau minggu pertama tu cuba attend yang saya kata online class tu lah kan. Dapatkan certificate, follow dia punya semua modul tu. Dapat certificate, dapat 5% in hand. Lepas tu dah boleh tahu, oh you interest kat mana, application mana yang you nak boleh buat. So minggu kedua tu familiar buat self learning. Minggu ketiga tu baru betul-betul model, dapatkan verification. Lepas tu berbaki 3 minggu terakhir tu try lah slowly buat report semua kan. Sebabnya lepas tu kita hanya ada final assignment saja tau. Final assignment ni satu, dia tak ada final assignment 1, final assignment 2. So final assignment dia akan cover chapter 1 dengan chapter 3. So that is the last chance lah. Kalau you tak buat betul-betul report you kena score lah dekat final assignment kan. Final assignment kita tak tahu soalan mana lagi. Okay, back to that one ya. So saya dah jawab. So jumpa dekat makmal komputer. Mungkin you boleh bawa laptop tapi saya rasa you dah boleh akses internet kat situ kan. You buat praksi sambil tu you dah boleh read online nota-nota yang berkaitan kan. So tak payah nak susah-susah bawa badan cukup lah. Lepas tu back to tadilah, kalau kata persist to error part of calculations tu, kena carilah apa punca dia, sama ada boundary condition salah assign. Kemudian you kata benda ni ada effect water pressure. Tapi the way you assign periodic line ataupun effect of water pressure not really indicate the problem kan. So kat situ nanti dia akan ada effect final calculations lah. And then lastly you kena tahulah apa yang you nak study sebenarnya. Kalau kata wall deflections tu, apa output yang you may expect. Mungkin you nak tengok dia punya stress kan, dia nak tengok strain dia. Kalau first excavation dengan last excavations, berapa dia punya deflection. Benda-benda tu lah yang you kena find out. Sebenarnya benda ni kalau you buat final year project dalam bidang geotrend dia adalah 2-in-1 lah benefit pada awak. Tapi saya tak tahulah how many of you yang buat project geoteknik, kemudian modeling and simulation become your study area. Okay, ada soalan lain? So please take part dalam learning activities. So saya nampak saya boleh identify students actively involved, engaged dengan learning activities. So daripada situ kita boleh agak lah dia punya performance tu macam mana. And if you have nothing to ask, okay lah, saya tanya last question. It's all about lebih kepada opinion lah. Okay, what do you say if you have a problems? For example, you nak buat slope stability. Okay, apa benda yang you perlu dapatkan maklumat? Faris? Faris ni kan? Faris ni mana?
Ya, ada. Hello.
Cuba jawab sikit.
Untuk apa tadi?
Slope failure.
Slope failure, dia kena ambil dia punya soil bearing.
Apa? Soil bearing? Okay, sekarang ni you nak buat back calculation ke? Sekarang ni failure dah berlaku tau. So apa maklumat yang perlu?
Failure dah berlaku.
Failure dah berlaku. Biasalah kan dekat KL kan, banyak projek dekat kawasan-kawasan cerun, rumah-rumah sedia ada pun dekat kawasan cerun kan. Dapat satu call. Contohnya you, ni situation saya, you ni pegawai JKR, you ataupun engineer PBT, dah dipanggil ke site projek lah, site failure tadi tu, slope failure. What are the things that you need to be done at the first place? Ni sebagai engineer ni, you mewakili majlis bandaran. Macam mana Faris Amirul? Alah, dia diam pula. Apa Faris? Bearing, what kind of bearing you are mentioned here?
Madam.
Yeah.
Maksudnya madam, slope failure tu dah berlaku, so kita nak determine first thing before kita recalculate balik dia punya slope ke, maksud macam tu madam?
Betul lah tu.
Oh ya.
Baik, sekarang nanti kan dalam PETSIS, saya just bagi tahulah kalau kata you nak study application dia iaitu slope stability. Dalam kes ni, slope stability ni dia ada dua. Satu slope yang you design at the first stage. Slope yang tak cut lagi. Kita tak buat any cut, kita tak buat any fill kan. Cut slope selalunya kita cut slope selalunya projek yang terlibat adalah kita potong cerun. Tapi tak buat apa lagi. So dalam PETSIS kita boleh design slope. When we talk about slope design ni in terms of dia punya slope height dia, kemudian slope angle. Kalau kata you want to do at the first phase yang mana kita nak design slope yang tak ada apa-apa cut activity kan. So kita nak tahu adakah slope design ni dia sesuai untuk single slope yang tak ada berm, yang cerun yang bertingkat-tingkat, ataupun steep slope ni terlalu steep sangat. Dia tak boleh single slope, dia kena buat berm slope yang slope ada beberapa tingkat. Bila berm slope ni you nak kena tahu pula kan one berm kepada second berm tu berapa dia punya angle slope dia, kemudian berapa dia punya tinggi dia kan. Semua benda-benda tu kita boleh design dalam PETSIS. Kes kedua yang saya tanya Amirul tadi ni, kes yang mana failure dah berlaku. Kemudian saya nak reanalyze ataupun recalculate for the best slope protection design. Sebab sekarang ni failure dah berlaku kan. So apa repairing slope design yang saya nak offer kepada kontraktor untuk dia buat kerja-kerja penambahbaikan cerun tersebut. Sama ada dia nak pakai shotcreting ke, tapi mesti dia kena tahu kan design slope tu berapa angle dia, berapa height. Bukan dia main letak soil anchoring ke, main letak micropile ke apa kan. At least dia kena design dulu. So dalam PETSIS kita boleh buat kaedah tu. So antara parameter yang you kena dapatkan adalah kita panggil residual shear strength parameters. Maknanya sekarang ni nilai strength tu dah reduce lah daripada asal sehinggalah pada keadaan failure tu dah berlaku. Dia dah reduce lah. So kita nak tahu nilai C terakhir tu berapa, nilai V terakhir tu berapa. And then dalam PETSIS kita ada satu function kita panggil sebagai shear strength reduction technique. The shear strength reduction technique will help you to determine the factor of safety of the slope design. Maknanya nanti walaupun you buat back calculations ke ataupun you buat front calculation ke kan yang future ataupun yang kemudian, you can have this function of SST untuk determine factor of safety just to ensure the design that you propose is safe or not safe. So that's the thing yang you perlu take considerations lah bila you nak design for slope ke, you nak design untuk any foundations. If you say just now soil bearing selalunya kita relate dengan foundations. Kalau you talking about slope stability, we always concern on the factor of safety dengan dia punya slope design parameter. Dalam foundations pun bukan kita tak concern dia punya parameters ke apa, tapi dia more applicable when you design foundations. Kita akan tengok dari segi bearing capacity. Factor of safety pun kita akan calculate. But the first one is a bearing capacity. Q ultimate dia berapa? Q ultimate is a QF. And then kalau you dah tahu QF, you boleh dapat lah factor of safety kan dengan you manual calculations ke ataupun you set on PETSIS ke, atau applications yang lain adalah excavation, consolidations, embankment. So benda-benda tu lah yang you kena buatlah dulu study sikit-sikit kan, go through dia punya manual, tengok YouTube ke mana yang mudah. Sebab projek ni bukan projek 1 tahun. Projek CG612 ni projek lebih kurang 3, 4, 6 minggu je kan. Kalau boleh biar projek you buat tu, PETSIS ni bukan you copycat daripada manual PETSIS. Kita boleh detect tau students yang kononnya dia run PETSIS tapi sebenarnya dia copycat result daripada PETSIS manual. Macam mana kita encounter that things. Kita tak macam on part of me, saya tak boleh nak pergi say to the students you did wrong sebab benda dah lepas kan. The penalty will be happen on the carry mark lah, penalty kat situ, markah untuk projek tu kita kurang, kat situ tak ada value of ethic. You as a future geotechnical engineer, boleh ke you cheat macam tu? You cheat report? Tak boleh kan? So you kena present what you are doing. Kalau you buat last minute, kita tahu lah kerja-kerja last minute ni macam mana. Dia ambil manual punya, manual practice punya result, dia masukkan dalam words dia tulislah report tu. Macam seolah-olah dia punya run analysis. We can have the true or false punya report yang kita boleh detect. Ataupun you seorang partnership, project partnership. Tapi kat sini dalam projek CG 612, dia bukan projek berkumpulan, dia bukan partnership ni projek. Dia projek individual. Tak ada cerita aku run, kau tulis report, lepas tu kita just tulis nama individu. No, kita boleh detect juga. You datanglah, you hantarlah hari kemudian ke hari awal ke hari tengah-tengah ke, kita boleh detect. Oh, student A sama dengan student B ataupun student C. Dari segi reporting, result dia. Walaupun benda ni semua computerized kan, you masuk copy paste dalam words, tak boleh nak detect kan A dengan C ni beza kat mana sebab semua menggunakan standard font writing. Tapi kalau kita boleh detect, takkanlah you all boleh guna practice sebesar-besar alam case study, project sources daripada artikel, you hanya guna satu artikel je. Guna kan banyak lagi artikel database yang you boleh jadikan rujukan you untuk verification data kan. Kemudian takkanlah run practice, padahal run practice ni dekat desktop yang lain bagi result sama. Impossible kan. Kalau you rasa you dah cukup smart, ada orang lagi smart. Okay. Me myself pun, if I think that I am smart, I'm not, because ada lagi yang smart daripada saya. But this thing they will carry your attitude lah. I'm not encourage you to do that lah. Ada lagi tak? Ada lagi? I think that there is no questions anymore. I pun dah bagi satu soalan. I tanya you soalan, ada soalan tak? You pun tak bagi soalan. So win-win situation, I open to the floor, I answer, and I hope that you have learned something from here, from this class, and hope that it is benefited for you in the next class. So all the best, good luck, and see you soon lah kalau kita ada peluang lagi untuk berjumpa. Okay, Assalamualaikum.
Thank you, madam.
Waalaikumsalam. Thank you, madam.